Alright troops, Yoker Uni presents
Right, know that feeling you get when you've pure been putting something off for as long as you can, but you've eventually got to do the thing you've been putting off, right? I don't want to get philosophical on you, let's just say it's the same feeling you get after you've gone for a pure spicy curry the night before and you're putting off going for a jobby because you just know it's gonna burn. Well, that's how I pure feel about all this crap I'm talking about, right? Batteries. Who the hell wants to know about batteries? You plug in your phones to charge your battery, then you can use it for a couple of days. Big wow, man, big wow. Before we pure delve deeper into the battery button crap, you need to know about charge. Charge is the wee bits that actually move in the wires and that. They are called electrons and have a negative charge. They want to boost away from the negative round to the positive bits of a battery around conductors like wires and stuff like that, right? Years ago, right, we all thought charge was positive, but then we found out there were electrons and negative, and we're all like, oh crap man, we need to change all our textbooks. Well, we did, but America were like, hey man, we ain't changing. We'll just call it conventional current and say it goes from positive to negative. Like my wee American accent there, troops, alright? Thing is though, it doesn't matter what way it goes, the size of the current is pure the same, whatever you use. But still, they might have made an effort, Americans. Charge is named after Charlie Coulomb. His dad was from France and his mom was from Maryhill. 1 coulomb of charge is this many electrons. There's more electrons in a coulomb of charge than there's been seconds of time since the Big Bang. There's a Yoker factoid and a half for you. Get in. Anyway, right, a wee chemical reaction inside a battery gives you a voltage, which I call voltage, or a potential difference between the wee positive bit and the wee negative terminals. Inside a battery, there's a wee mad chemical reaction that pure forces electrons to go from positive to negative. They don't like that and they're like, what the hell's going on? What am I doing this for? They pure get stored up with energy when they're doing this, alright? When they get out of the battery into the circuit, they've got pure stored electrical potential energy in them. They can take this energy around the circuit to the wee mad resistors and bulbs and crap like that. When you pure change the energy they have stored into things like light and heat and all that stored energy stuff, right? A circuit pure works straight away because all the mad conductors and that are pure filled with mad electrons that can move. Just think about a big mad conga line at a party. One person moves, they all move. Electrons in these circuits heavy actually only fart about around 10 centimetres every hour. Mental or what, man? A battery pure gives every coulomb of charge that comes out it with the same electrical energy. This is called a voltage, which is joules of energy per coulomb. Named after some wee guy called Alessandro Volta, who was an Italian count. So here's a wee mad video I've pure made up to show you something pure mental. Here's a wee simple circuit with a battery, a switch and a bulb. I've pure packed a wee multimeter for Rapid Electronics, brilliant man, Rapid Electronics, which is set to voltmeter mode, which measures volts. What this is doing right now is measuring the VTPD, which is the terminal potential difference or voltage that a battery gives out. When the circuit isn't working, there's no current. The VTPD is equal to the energy that the mad chemical reaction gives to each coulomb of charge. This is called the EMF, or electromotive force, and that. It's unbelievable.
You're unbelievable.
What are you talking about, Valdo?
The band Echo EMF, you're unbelievable.
No, it was KLF.
No, they were last train to Central Station.
What? Well, who the hell did Freedom then?
QFX.
Oh, you don't like doing your something, man.
Right, now Deco's brain's mashed up with my musical knowledge, let's get back to batteries. The EMF is only seen at the VTPD when nothing is connected, alright? Look here what happens to your mad VTPD when I pure give the circuit a current by pressing the wee mad switch. What? the VTBD goes down. So the energy that the battery gives out and what the circuit pure uses isn't as much as the EMF for the chemical reaction. What? Turns out the same thing happens with two bulbs and all. The only way for this to happen is if you have a wee resistor inside your battery which pure uses up some voltage before it even leaves the battery. This is called your mad internal resistance, and we call the voltage trapped inside the battery the lost volts. Oh man, pure Indiana Jones and your mad lost volts. What a pure dramatical name. It's heavy actual simples, by the way. Your mad Kirchhoff's voltage law pure says in that the EMF for all your batteries equals all the mad voltage drops around the circuit. Here's a wee bit of equation work, and here's some versions of an equation that you might need to use for your higher exam, know what I mean? One thing you need to remember, that if you pop a wee wire across your terminals of your battery to pure short it out, then charge flows in it. This current is called Imax, since it's pure only got your wee internal resistance in the circuit, because we say the wire's getting the ohms and that, right? So Imax is just your EMF divided by your VR. Well, it isn't really exciting stuff, is it? But it is examinable, even for the new higher physics, alright? So get it learnt, big chap. Here's a wee single fish worked example for you. To pure accompany it, let's get some QFX on. Tune!
To the east, there are colors in the sky. Anytime you need some peace, come along and stay with me, yeah.
Yeah, by the way, one thing I pure witnessed with my own two eyes in that, man, was this. When I had a wee motor in a circuit and I tried to slow it down, the VTPD pure dropped even more. It's pure as if like, the current in it went tonto and went up higher, so there was more lost volts inside the battery when I tried to pure stop it with my fingers and that. Why would the current go mental when I tried to slow down the motor? Get your thinking baseball cap on me, man. Chachi Versace.